We learned that radioactivity can be described by this expression, dN over dt equals to minus lambda n. Solving this equation gives us n equals to n naught e to the power minus lambda t, where n is the number of radioactive nuclei at time t equals to 0. In the slides, we also defined the time constant tau. It's 1 over lambda, where lambda is the decay constant. We'll come back to lambda later. We also have a definition for the half-life, which is the time taken for half the radioactive nuclei to decay. So combining these two expressions, all right, using the definition of half-life, right, we have n naught over 2 equals to n naught e to the power minus t half divided by tau. The n naughts on both sides would cancel, right? And we take the ln on both sides, all right, we get ln 2 equals to t half over tau, right, which gives us an expression for the half-life in terms of tau. Another expression that is useful, and that comes from here and here, and is useful, so n equals to n naught half power of t over t half. I'll leave it to you as an exercise to derive this expression. All right. The third expression that we worked with was activity, which is given as A equals to lambda n. All right. Now, point to note, all right, from here, right, you notice that the decay constant is a proportionality constant. All right. So from this expression, we have first of all, right, that A is directly proportional to n. Right. That means that all the expressions that we have earlier worked out, all right, can also be replaced by n. Another point to note, all right, is that the activity has SI units of the back row, which is equivalent to per second. Right? So that's why it's important that when you're making use of this expression, you need to make sure that the unit for lambda is also in terms of per second. Right? So coming back to this expression over here, right, you see that there's a relationship between tau and lambda. Right? So if you're given the half-life, you're going to make sure that your half-life is converted into seconds before you make use of this expression over here. Now, we don't have to worry about that when you're working with this expression. Right? In this case, right, all you have to make sure is that the units for t and half-life are the same, right, because after all they will cancel.